All right, again, inverse functions, part 5. We stopped, the video stopped here in when we are finding the points, the point of intersection between, if we have point of intersection, and yes, we do have, between y equal x and the curve. In this case, we said that x equal y, so we will have the same point at abscissa and the same as ordinate. And this point, let's say it's point B. So B has coordinates 3 plus radical 5 over 2, or 2.61, abscissa, and same as ordinate. And this is good. This is good. What other thing we can do? That's the very important thing I said before in video part 4. We just said that since f prime of this endpoint equals 0, then we have horizontal tangent. And we found that f of 1 equals 0, right? So the point, one of the endpoints is 1 abscissa 0 ordinate. The other, we don't have endpoint because it goes from infinity to infinity, right? So that's why we have just one point. Let's say it's point A. And let us go back to the curve we are drawing. 1, 0. So this is point 1. Abscissa 0 ordinate. This is point A. We said here we have horizontal tangent because the derivative at this point, was 0. F prime of 1 is 0. F prime of 1, not F prime of 0. Okay, so it's F prime of 1, sorry. This one. So in part 4, we have mistake here. It's F prime at point 1. If we substitute 1 instead of x, right? So it's F prime of 1. It's equal to 0. This means we have horizontal tangent here. Okay, so horizontal tangent. So very good now, because we know that the curve passes through this point, its endpoint, and it should pass through by this point because it's point of intersection between the curve and the straight line y equal x. And here at A we have horizontal tangent, so we draw as tangent, right? It's just part of the parabola, right? Because we need only from 1 to plus infinity, from point A and above. Okay, so it goes like that. I know my drawing will not be neat here, but it will go something like that. Okay, let me erase this from here, portion 1. All right, so this is our curve. This is the curve of f. That's great. How we draw the curve of f prime now, of f inverse, I mean. It's very simple. Since this point A has abscissa 1 ordinate 0, all right, any point we have symmetric with respect to y equal x. That's what we said in the properties, right? In the property up. So in the property, we studied that in video part 4. So the inverse of A will be another point of abscissa 0 ordinate 1. Abscissa 0 ordinate 1. Y equal x, simply. Instead of yx, instead of xy. This point. So we have here, instead of horizontal tangent, we have vertical tangent. And that's also we said in the properties. If we have horizontal tangent, then if x equal 1 here, if y equals 0 is horizontal tangent, so x equals 0 will be a vertical tangent. So we have vertical tangent at this point. Okay, and also let's say this point is A prime. Okay, so also we have tangent here, and it also should pass by point B because y equal x. Okay, simply it's the curve of the inverse. Well, that's neat. I like that. Okay, let's continue to part 2. Part 2 was part B actually was find f inverse prime of 1. Part B was find f inverse prime of 1. All right, f inverse prime of 1. Okay, here you have to be careful. F inverse prime of point 1. So first we need to find f inverse. We didn't find it yet, right? What is f inverse equals to? Let's go and find f inverse. F of x was what? Was y equal x squared minus 2x plus 1. We did find that before, by the way. And we can say that y equal, if you remember, we did that before, x minus 1 to the power 2. And we square root both sides, so it's radical plus or minus radical y equal x minus 1. But x minus 1 is greater or equal to 0 because the interval goes from 1 to plus infinity. This means we not just choose that x minus 1 only radical y. So x will be equal radical y plus 1. Then y equal radical x plus 1. And this is the inverse function. That's great. So let me fix the page and we continue. So since the f inverse is y equal radical x plus 1, we want to find f inverse prime of 1. We need to find f inverse prime of 1. Let's find f inverse prime first. What is f inverse prime? The derivative of radical x plus 1. For sure, derivative of 1 is 0. What is the derivative of radical x? It's derivative of radical u. Remember, derivative of radical u, it's u prime over 2 radical u. This is the rule of it. So what is the derivative of the x inside? It's 1 over 2 radical x. This is f inverse prime of x. But we need to find the f inverse prime of 1. So we substitute instead of x its value, and it's going to be 1. This means 1 over 2 is the f inverse prime of 1. Okay, now we might in other problems, and we will, because I will give you a problem now, and you will see that you might face a problem finding f inverse. Not every time we can find an f inverse easily. If it is not required to find the f inverse like we did here, which is radical x plus 1, it was easy to find, but sometimes it's not easy. So how can we find f inverse prime? There's a rule. There's no more time. I will not explain it, but you have to know it. You will use it. F inverse prime of y is equal 1 over f prime of x. This is very important rule. Very, very important rule. So study it and memorize it. F inverse, and I will explain it later why we have it, why we have this rule. F inverse prime of y. Okay, just in case we don't have f inverse, we use it. Or it's not required to find f inverse, or we can't find f inverse because of hard functions sometimes, right? So we say what? We have the y equal x squared minus 2x plus 1. This is the original f of x. What's the meaning of f inverse prime of y equal 1 over f prime of x? So the number here is y, and the number here should be x. Okay, what do we have the number here? We need to find f inverse prime of 1. So the y is 1. This is y. So this y, we put it equal to 1. We got what? We got simply x squared minus 2x plus 1 to the other side minus 1. So what left is 0 to x equals 0. Factorize x into x minus 2 equal to 0. Either x equals 0, which is rejected, right? Or why rejected? Because it's out of my domain. Check the domain. It's from 1 to plus infinity. 0 is rejected. Or x minus 2 equals 0, then x will be equal to 2. This means my x is 2. So since f inverse prime of y equal 1 over f prime of x, so instead of finding f inverse prime of y, which was 1, we find y over f prime of x, which is 2. I don't have that much time. F prime, let's find it here. F prime, we found it as 2x minus 2. What is f prime of 2 then? It's 2 times 2 minus 2, so it's 4 minus 2, it's 2. This means the answer is 1 divided by 2. Okay, we can find f inverse prime of 1 in 2 ways, and this way is very important because sometimes we can't find the f inverse again. Okay, so see you next video. End of part 5, I guess.